In today's class, we will go through physical properties of ethers. Before this, we have already done in previous chapters physical properties of alcohols, physical properties of phenols, haloalkanes, haloarenes. Right? So before we go ahead with this, let's just generalize some of the things that we normally study in physical properties of any organic compounds. Right? Generally, in physical properties, we study about physical state, whether the given organic compound exists as solid, liquid or gas, right? And how this physical state varies with molecular mass of organic compounds, right? Then we study about color, we study about odor, right? Then we see about the density, right? And then we see the variation of density of molecular masses. Density of organic compounds, how it varies with molecular masses. We know that with increasing molecular mass, density increases. Then we talk about, let's just take down, we study about physical state, right? We study about color, we talk about odor. We study density, then we study about dipole moment and polarity, right, which is based on the structure, right? When we study about the structure of any organic compound, we look at the charge separation, which depends on the electronegativity difference, right? Based on that, if the molecule is polar, right, it has a dipole moment, right? So then we study about solubility, right? We study about boiling point, melting point, boiling point, right? And just remember, based on our previous lectures, solubility and boiling point depends on hydrogen bonding, right? And association of molecules, right? That brings association of molecules, of organic molecules, that bring these molecules together, right? Association of molecules that bring them together, right? These are some of the things that we study. So in case of boiling point, if molecules associate, right, due to hydrogen bonding, right, if molecules, right, of any organic compounds are able to form intermolecular hydrogen bonding, that means hydrogen bonding between individual molecules, then its boiling point would be high, right, because hydrogen bonding helps in the association of molecules. When the molecules are associated, they are more close, then you need to give them more energy in order to separate them, right? So their boiling point will rise. Now, other thing is your polarity. Polarity, when you have a dipole plus minus, if you have a polar molecule that has a positive end and a negative end, that will also add to the association of molecules, right? So these two things will add to the association of molecules. When we talk about solubility, we know the general concept of solubility, that if we dissolve any organic compound in water, if that organic compound can interact with water, right, then it will be soluble in water. If it cannot interact with water, it would not be soluble in water. So when we talk about interaction, we mean that suppose this is your liquid, right, suppose AA, this is your liquid, right, in which you are trying to dissolve an organic compound, right, and this is your solute, right? Now, in order for this solute to dissolve in this liquid, which is AA, the interaction between AB, that means when I dissolve this solute in this liquid, right, the interaction would be between A and B, right? Now this interaction should be equal to AA and BB, right, in order for this solute to dissolve in this liquid, in this solvent, right? The better is this, right? The better is this, right? More is the solubility of solute in the solvent, right? Now, if there is no such, if this interaction, AB interaction is less than AA and BB, then the solubility would decrease, right? Because now this AB, right, that means this solute and solvent are unable to interact, so solubility will go down, right? So what kind of interactions we have studied when we talk about solubility of organic compounds in liquids, in water generally, we study hydrogen bonding, right? Hydrogen bonding is an interaction, right, that can make your organic compound soluble in water, right? For example, if this is your alcohol, right, it can form hydrogen bonding with water like this, right? So that means alcohol would be soluble in water. But remember, in case of organic compounds, whichever organic compound you take this R group, this R group is not water soluble. We call this as hydrophobic, right? So as the molecular mass of alcohol on any organic compound increases, this R increases, right? So when this R will increase, that means this hydrophobic part, which is not soluble in water or which does not like to interact with water, right, is increasing. So this increase in R or molecular mass will decrease the solubility of alcohols, mainly higher alcohols in water. So that's why we say, when we study about different organic compounds, that higher alcohol or higher organic compounds, ethers, alcohols, haloarenes, are insoluble in water because of this alkyl groups, that it will increase, the size of the alkyl group will increase with the molecular mass, so its solubility will decrease because R is your hydrophobic, right? So I hope till this point it is clear. Now let's just come to our main topic, which is physical properties of ethers. When we talk about physical state, your dimethyl ether, right, and your ethyl methyl ether, right, both these are gases, right? Other ethers are liquids, right? And your and your aromatic ethers, right, they are also liquids, right, with characteristic odor, right? So these are gases, these are lower ethers, these are gases, and your other ethers are liquids, right? Now when we talk about, let's come to the second one, density. Density, we know it increases with molecular mass, right? So as the molecular mass of ethers will increase, its density will increase, right? But all ethers are less denser than water, right? All ethers are less denser than water. When we talk about polarity, we know that ethers are like this. You have R, you have R dash, these may be same, may be different. You have these lone pair of electrons, right? Now due to these lone pair of electrons, this ether molecule, it has same shape as water molecule, right? But due to repulsion, right, due to repulsion between these, you have an angle between these is 110 degree, right? So this is now 110 degree. So this molecule is not linear, right? If you talk about the dipole moment, this is negative, this is negative, this is positive, this is positive, negative. It's like this. It has a net dipole moment. right? Because it has polarities and this molecule is not linear, right? So the dipole moment of these two bonds, right, CO-CO bonds, do not cancel each other, right? Whereas if you remember, we used to do it like this, right? It adds to these two dipole moment, adds to form this net dipole moment, right? So ethers are polar molecules, right? They have a dipole moment. Now let's come to solubility and boiling point. Like I said here, solubility of ethers. We know that ethers, these are ether molecules, right? Now in ethers, when these ethers dissolve in water, right, when we dissolve these ethers in water, right, this is how water will look like: negative, positive, positive. Here you have positive, negative, positive, right? So when such a molecule is dissolved in water, it will form hydrogen bonding with water. Between electronegative oxygen and between electropositive hydrogen of water, there is hydrogen bonding, right? Now since we have hydrogen bonding here, lower ethers are soluble in water. Now since based on this explanation, lower ethers can well interact with water due to this hydrogen bonding, right? They can form hydrogen bonds. So lower ethers are soluble in water, right? Now let's talk about the higher ethers. In higher ethers, this R group, this hydrophobic part, will increase. Now when this hydrophobic part or the size of the alkyl groups increase, what will happen is the solubility will decrease, right? Like I said here, this R group, alkyl group, is hydrophobic. It doesn't like to interact with water, right? So when this two alkyl groups will keep increasing, right, so the solubility will decrease, right? That is why we say that higher ethers are insoluble in water. Why? Because of the increase in size of the R groups with increasing molecular masses, right? Now let's come to boiling point. When we talk about boiling point, what we are basically looking into association. If there is more association between molecules, more would be the boiling point, right? Now let's see association. Just remember, here we said that it has a dipole moment. It is polar molecule, but the dipole moment is very less in case of ethers, right? So two things we know that can associate molecules of ethers, right? Two things are, first is, so association between molecules occur due to two things. First is your hydrogen bonding, right? So let's due to polarity, right? Second is your hydrogen bonding, right? This is how these ethers look like, right? We have no hydrogen atom in ethers, right? Although if you just look at this, you have hydrogen atom. If we talk about dimethyl ether, we have hydrogens, but these hydrogens are not directly linked to this oxygen atom. Since hydrogen is not linked directly to this oxygen atom, so it cannot form hydrogen bonding between one another. There is no intermolecular hydrogen bonding because hydrogen is not directly connected to oxygen atom. So no intermolecular hydrogen bonding, right? And if we talk about polarity, dipole moment is less, right? The polarity of ethers is less. They are less their polarity is less, right? So their association due to polarity is very less, right? So association, they are less polar, right? So association is also less, right? Association is also less. So we say since they are less polar, their association is less, right? Hydrogen bonding, no hydrogen bonding, right? So association of ether molecules is less, right, compared to other molecules. If we talk about, compared to other organic molecules like alcohols or isomeric alcohols. If you remember, in alcohols, if this is your alcohol, right, kind of this, between alcohol molecules you have hydrogen bonding, right, due to which molecules of alcohols are associated with one another, that will increase their boiling point, right? But in case of ethers we have no hydrogen bonding. No intermolecular hydrogen bonding means no association, right? No association due to intermolecular hydrogen bonding, but we have association, less association due to polarity, because these molecules are polar, right, based on their structure. We already know that. So that is why their boiling point is less than isomeric alcohols, right? Their boiling point is nearly same as those of alkanes, right? So boiling point of ethers, is less than isomeric alcohols, right? We know that isomeric alcohols we have intermolecular hydrogen bonding, due to which association will occur between molecules, that will raise the boiling point. Whereas in case of ethers there is no association, no hydrogen bonding, no association, so boiling point would be less, right? So you have to give them less energy in order to boil, in order to separate the molecules of different molecules of ethers, right? So what about aryl ethers? If we talk about aryl ethers, right, that has benzene nucleus, right, their solubility, they are almost insoluble in water because of their higher molecular mass, right? We know that benzene has high molecular mass, right? So aryl ethers are insoluble in water due to benzene nucleus, right? I hope all this is clear, right? Thanks.